Assalamualaikum warahmatullahi wabarakatuh. My name is Nahafiza binti Luhasan. We are Group 6, which are from Software Development class. Will present all of you about Advanced Encryption Standard, which is called as AES. What is AES? AES is the Advanced Encryption Standard, which means a symmetric block chipper chosen by the US government to protect classified information and is implemented in software and hardware throughout the world to encrypt sensitive data. Now, I will talk about the history of the Advanced Encryption Standard. AES, also known by its original name, is a specification for the encryption of electronic data established by the U.S. National Institute of Standards and Technology, which is NIST, in 2001. AES is a subset of the original chipper developed by two Belgian cryptographers, Vincent Rijman and John Damon, who submitted a proposal to NIST during the AES selection process. Rindel is a family of chippers with a different key and block sizes. AES became effective as a federal government standard on May 26, 2002 after approval by the Secretary of Commerce. AES is included in the ISO/IEC 810333 standard. AES is available in many different encryption packages and is the first and only publicly accessible chipper approved by the National Security Agency, which is NSA, for top secret information when used in an NCA approved cryptographic module.
Assalamualaikum warahmatullahi wabarakatuh. My name is Siti Nashuhada binti Muhammad. Now I will explain about features of Advanced Encryption Standard. What is features of AES? AES is the selection process for this new symmetric key algorithm was fully open to public scrutiny and comment. This ensures a true, transparent analysis of the design submitted. National Institute of Standards and Technology specified the new advanced encryption standard algorithm must be a block chipper capable of handling 128-bit blocks using keys sized at 128, 192, and 256 bits. Other criteria for being chosen as the next advanced encryption standard algorithm included security. It is competing algorithms were to be judged on their ability to resist attack as compared to other submitted chippers. True security strength was to be considered the most important factor in the competition. Secondly, cost. It is intended to be released under a global, non-exclusive and royalty-free basis. The candidate algorithms were to be evaluated on computational and memory efficiency. The third one is implementation. Algorithm and implementation characteristics to be evaluated included the flexibility of the algorithm, suitability of the algorithm to be implemented in hardware or software, and overall relative simplicity of implementation.
Next, we go to AES algorithm. Okay, AES algorithm we have 6 types. Okay, first we have regional, Mars, RCC, serpent, and two fish. Okay, we choose for our group we choose algorithm which is regional and Mars because these two is most popular among among these five. Okay. Regional it is not a fiesta chipper. It works in parallel over the whole input block. Okay. hardware and software across a variety of platforms, such as PC and others. Okay. It's a block chipper which works iteratively with block size 128 bit, but also it can be 192 or 256 bit. Okay, the key length is 128, 192 or 256 bit. Okay, it's almost same with the block size. Okay, number of rounds is 10, 12 or 14. Okay, the key scheduling is 44, 52 or 60 subkeys with having length 32 bit. Okay, each round of this rational is a uniform and parallel composition of 4 steps. Okay, firstly sub-byte. Sub-bytes. Okay, first is byte to byte by byte substitution using 5 bots. Okay, second is shift rows. Okay, shift rows is a computation which cyclically shifts the last 3 rows in the state. Okay, that is mixed columns. Mixed column is a substitution that use Galois fields, Hopsy Galois, with the arithmetic GF with multiple by 2. GF 2 of the power of 8. Okay, and the last one is add a round key. Add a round key is bit by bit, nor with an expanded key. Okay. Okay. Next we go to legendary state. Okay. Internally, the AES algorithm operation are performed on a 2-dimensional array of bytes called the state. Okay, so we have 4 rows. Each rows will containing NB bytes. NB columns constitute with 32 bit words. Okay, so state RC denotes the byte in row R, and state row column denotes the byte in row R and column C. Okay, the array of bytes in input is copied in the state matrix. At the end, the state matrix is copied in the output matrix. Okay, then legendary design. Okay, legendary design the operation performed on state like the state before for rows of bytes. Okay, the 1 to 8 bit key is expanded as an array of 44 entries of 32 bits words. 4 distinct words serve as a round key for each round. Key schedule relies on the S-box algorithm composed of 3 layers. Okay, first linear diffusion, non-linear diffusion, and key mixing.
Next we move to mass algorithm. Okay, mass is shared principle that works with a block 128 bits and variable key size. The algorithm is type 3-faceted network is 32 bits word. Okay, the word orientation should bring a performance for software implementation of mass architecture available today. A fully optimized implementation is expected to run at 100 MB per second. And hardware can achieve an optimized additional 10 times speed up factor. Mass is unique in that it combines virtually every design technique known to cryptographers in one algorithm. It uses addition and subtraction, S-box, fixed data dependent rotation, and multiplication. Okay, we move to mass operation. So it have 4 operations. First, addition, subtraction, and XOR. Okay, addition, subtraction, and XOR. This is a simple operation are used to mix data and key value together because XOR are interleaved with addition and subtraction. These operations do not commute with each other. Okay, the second one is table lookup. Okay, table lookup is used a single table of 512 32 bits. It's simple called as box. A problem of the table lookup is the slow software implementation. Okay, that's why SBOT lookup is only used rarely in mouse, where fast avalanche of the key bits is needed. Okay, the third one is data dependent rotation. Okay, data dependent rotation may lead to differentiate weakness. This problem is solved in mouse by combining this rotation with multiplication. Okay, the last one is multiplication. Multiplication used to be a problem in cryptographic algorithm because they were slow. Most algorithms use 16 multiplication per block. Okay, this should not be a big deal because for software realization, we have the problem that multiplicator needs much more chip space than adder or logical unit.
Assalamualaikum warahmatullahi wabarakatuh. My name is Nur Zuhaira Nasrin binti Basri. Will explain about encryption process. Here we restrict to description of a typical round of AES encryption. As we know, each round comprises of 4 sub-processes which are sub-byte, shift rows, mix columns and add round key. So I just take part of sub-bytes and add round key, and the rest will take over by Siti Noardini. What is byte substitution? This stage is simply a table lookup using a 16 by 16 matrix of byte values called as box. This matrix consists of all the possible combination of an 8-bit sequence. However, the S box is not just a random permutation of these values, and there is a well-defined method for creating the S box tables. The designers of Rindel show how this was done, unlike the S-box in DES, for which no rationale was given. We will not be too concerned here how the S-box are made up and can simply take them as table lookup. Again, the metric that gets operated throughout the encryption is known as step. Next, what is add round key? Add round key is each byte of the state is combined with a block of the round key using byte-wise exclusive OR. The 128 bits of state are bitwise exclusive OR with the 128 bits of the round key. The operation is viewed as a column-wise operation between the 4 bytes of a state column and 1 word of the round key. This transformation is as simple as possible, which helps in efficiency, but it also affects every bit of state.
Assalamualaikum warahmatullahi wabarakatuh. My name is Siti Noardini binti Ar-Razan. Now I will proceed with Zuhaira presentation. Now I will talk about shift rows encryption process. This stage is a transposition step where the last 3 rows of the state are shifted cyclically a certain number of steps. In shift rows, step operate on the rows of the state. It cyclically shifts the bytes in each row by a certain offset. For blocks of size 128 bits and 192 bits, row n is shifted left circular by n-1 bytes. For a 256-bit block, the first row is unchanged, and the shifting for the second, third, and fourth row is 1 byte, 3 byte, and 4 byte respectively. Without miscolumn, every byte of the ciphertext will not depend on every byte of the plaintext, but only the 1 byte of the same position. This will fully break AES because we don't have an avalanche effect on the whole text anymore. Without the row shifting, every column of plain text will only affect the same column of the ciphertext. This will break AES too. Now we will talk about miscolumn. This stage is a missing operation which operates on the columns of the state, combining the 4 bytes in each column. It also is basically a substitution, but it makes use of arithmetic. Each column is operated on individually. Each byte of a column is mapped into a new value, the expansion of all 4 bytes in the column. Thank you.